Okay, so hi all, a very good evening. Uh, First, can someone confirm is my audio clear and is the screen visible to everyone? Okay, thanks for confirming. So, yeah, good evening everyone. Welcome to the TA live sessions for AI search methods of problem solving. So, let me first start by introducing myself. I am Ritvis. I am a PhD student and I'm Prime Minister's Research Fellow working at IIT Madras. And I'll be taking these live sessions to solve some problems related to the course content. And these problems will be from the previous offerings of the course, right? And a good thing is that so previously when these live sessions used to be held, um, I was the only one conducting these live sessions. But then this time I think there is another PhD scholar who will be conducting live sessions. So there will be two live sessions for this course in this semester, and one of them will be today on Mondays, and the other one I think will be on Saturday. Some of you may or may not have attended it already, the one that was conducted last Saturday. Did any of you attend the previous live session? Okay, that's great. Yeah. So it's so these two sessions are at different times. So it's up to you. Whichever time that you prefer, you can choose to attend either one of them or both of them. Or if the timings don't work for you for any of them, it's okay. You can skip also, because these sessions will be recorded and they will be uploaded on YouTube, and you can access the links anytime you want, and they will be made available to you through Swayam portal itself, so you don't have to worry even if the timings don't suit your schedule. Okay. So a couple of other things that I wanted to clarify is what we are going to do in this session. So we'll be having 12 sessions at least, corresponding to the 12 weeks of the course, and every week we'll be taking up that week's content from the course, and then we'll be discussing some sample problems which will be in the same format that you will expect in your weekly assignments. Okay. So there will be some MCQ type questions, there will be some multiple select questions and fill in the blanks or things like that. Okay. And the aim is that by attending or by solving the problems that we discuss in these live sessions, you will be able to answer your assignments better. You'll be also able to get your doubts clarified if any, and yeah, that's the aim. Second thing is that if you have any questions related to the structure of the course or the content of the course, well, not really content, but yeah, the logistics of the course. For example, things like format of the exam, duration of the exam, what kind of questions will appear in the exam, or anything that is related to exam, that unfortunately I won't be able to help you guys with, because I am in no way involved with the exam of this course. My only responsibility is to conduct these live sessions and hopefully help you guys get a better understanding of the concepts to whatever extent that I can. Okay, so do any of you have any questions for the live sessions? Then you can please feel free to unmute yourself and let me know. Okay, so I hope. Okay, where can you find live sessions on YouTube? Good question. So, usually what happens is, because this is just the first week, as I record, as this session is happening, I'm recording it simultaneously, and soon after the session has ended, I will upload it on YouTube, and that link I will share with the NPTEL team. Okay. And the NPTEL team's responsibility is that that link will be made available to all the people who are enrolled in the course. How that is done, that I'll show you usually how that is done. So this is your home page of the Swayam portal, right? That you might see when you log into your Swayam portal and go to the courses. So here you have different things. You have week 0, week 1 and week 2, right? Over here, the NPTEL team will be adding another section called problem solving sessions. Okay, below books. So you see a books over here, right? Below this, there will be another section added called problem solving sessions. When you click on that, that will lead you to a Google Sheet, and that sheet will be containing the links to all the live sessions as well as the material that we are going to use to conduct these live sessions. Okay, I hope that resolves that query about how you can access. Anything else before we get started for the day? Okay then. So yeah, so the slides that I'll be using, they will be from the previous offerings of the course again. Okay, so as you can see, the slide date is from last year, so don't worry about that, that is intentional. And all these slides are already uploaded in a drive folder, and I have already communicated the link to the NPTEL team. So maybe in a week's time or so, you should have access to that link yourself. Okay, so okay, for today, let's start the session. um, Okay, so I'll switch off my video because there's a latency issue with the net connection I'm using. So I can switch it on again after a while, but for the sake of maintaining the connectivity, let me just switch it off. Alright, so let's start the session for today. So this is the first question. So as you might have seen, this week we are going to discuss some questions from week 1 content of the course, or even week 0 content of the course, because that's like the very initial introductory beginning week, right? So yeah, this is the first question in front of you. um, Okay, so some of these questions may overlap between today's session and the Saturday's session, which will be taken by another PhD scholar, right? So that's fine. Okay, if you have any queries regarding those common questions or even questions that are not common, you can always feel free to unmute yourself and ask any questions at any point of time. Okay, so this is the first question in front of you. So here we are dealing with so there are two states given to you. Okay, one is called the initial state and one is the final state. Okay, and this is one of the classic problems in AI. So you imagine that there is a robot which has only one hand, and with this one hand the robot can do very specific actions only. Okay, it can only pick up one box and put down one box. Okay, and even that is differentiated when the robot picks up a box from a top of another box, or it picks up a box directly from the table. Okay, and again, while putting down the box, it can put down the box from its hand on top of another box, or from its hand on top of the table directly. Okay, so these are the specific actions that the robot can perform, and you have to make the robot uh, take a certain set of actions one after the other, so that you go from initial state to final state. Okay, that is the whole idea of the problem, but you don't have to solve the whole problem um, right now. Okay, um, for now, the question asks which of the following are valid actions among the four options given to you. Okay, so while you think about the question, there are a couple of questions that I saw see in the chat box. I'll address them one by one. Okay, so Rohit asks, can you increase the maximum number of people who can join? Uh, Rohit, I suppose that should be taken care of. Let me check. Yeah, I think I have enabled auto login for everyone. So anyone who wants to join should be able to join. If it's a question of the number of the maximum limit of people who can join, that is something that I'm not sure about. I'm using the official Gmail account or official ID of my institute to conduct this session, so that should have a large capacity. But yeah, I will check this further and get back to you with a clarification maybe in the next session. Okay. And yeah, for the next two questions, I think they're the same questions that people who have registered very recently. So yeah, that's no problem at all. You can feel free to join in the live session and um go with the flow. But yeah, as long as the joining date is there, you can feel free to join at any point of time. But I would highly recommend that don't rely solely on the live sessions. Okay, this is for everyone, not just for people who have joined recently. I would highly recommend you definitely watch the lecture videos, definitely solve the lecture assignments, even the examples that are being discussed in the lecture videos. You should definitely try to solve them on your own, and then you can additionally solve the questions that we are going to discuss in the live sessions. Okay, so that should be more than enough for you to get a good grasp of the course content and score well in your weekly assignments as well as your final exams. Okay, anything else? All right then. Okay, so we have one candidate answer. Someone says B, C, and D are valid options. Let's have a look. Okay, so option A is put down M. Okay, now this cannot be a valid action, right? Because um, in order for the robot to put down M, it should have M in its hand first, right? But here we see that in the initial state, M is already on top of another box called I, right? So A cannot be a valid option. Let's look at B, pick up V, right? Now this seems to be fair because it can pick up V from the top of the table. Now let's look at C, which says stack Y on G. Okay, now think about it. Again, Y is on top of W, right? So before Y can be stacked on top of G, the robot must perform the action of unstacking Y from top of W. Do you follow? Right? Because of that, I think C will not be a valid option. What about option D? It says unstack R from O. Now this seems correct, right? Because R is on top of another box called O, and the robot can remove R from top of O, and this would be called an unstacking option, right? So the correct options for this question are B and D. So any confusion, any doubts about this question? I also see that there is one hand raise, so you can please feel free to unmute yourself and ask any question. Okay, you don't have to raise hand every time. Um, yeah, I'll wait a couple of seconds. Okay, if it's clear, then that's great. Let's move on to the next question for today then. Okay, so now we have the same problem, but the question is a bit different. So now you're told that if pickup and unstack actions take 2 units of time, okay, so one pickup action takes 2 units and one unstack action takes 2 units. Okay, let's assume that. Okay, this 2 is an arbitrary number. Okay, we have not really done experiments to arrive at this. And then put down and stack actions take 1 unit of time each. Then what is the shortest time in which we can reach from the initial state to the final state? Now you have to solve the whole problem of going from initial state to final state, and you have to see what is the shortest way in which you can do this, and then you have to calculate the time taken for all those actions that you took. Okay, and assume that you are not taking any long breaks in between. So I'll let you think about this question for a while in the meantime, and then after maybe a minute or so we can discuss the solution. Okay then, so let's have a look at the solution. So we have a different number of answers in the chat box. Let's have a look at what the correct solution should be. So this is the final solution that we have to adopt. Okay, so this is the initial state that we were in. Okay, and the first thing that we have to do is make sure that we have this similar order of boxes that we have in the final state. So you see the bottommost box in the final state is a V box. Okay, and then on top of that V we have an I. So the next thing that we want to do is we want to place a I on top of V. But in order to do that, we must first remove M from top of I, right? So the first action that we will do is we will unstack M from I. Okay, we will unstack M, remove M from top of I, and this will take 2 units of time. Okay, now remember, once we have unstacked M from top of I, the box M is in the robot's hand, right? And the robot must place down M somewhere for it to pick up I, right? So where should it put down the box M? It should put it down on the table somewhere, right? Because that will take lesser amount of time, right? 1 unit. So it will put down M. This is the second action that it will take, and this will take 1 units of time. Now the robot's hand is free. Now it will unstack I from B. Okay, this is the third action that it will take, and this will take 2 units. And once it has unstacked I from top of B, it has I in its hand, right? Next it will place it on top of V. So it will stack I on V. Okay, remember, stacking on top of another box, not putting down on the table. Okay, and this will take 1 unit of time. Okay, now we have V and I. Yeah, is there any doubt? Okay, that's good then. So we have V and I as of now, right? Now we want B on top of I, right? So in order to do that, we will pick up B. Remember, there is nothing on top of B right now because we have removed M. We have already placed I on top of V. So B is empty. Nothing is there on top of B. So we will just pick up B and then place it, stack it on top of I. Okay, so we are at the sixth action now. Okay, this one. Yeah, I see a hand raise. Please feel free to unmute yourself, and if you have any doubts, please feel free to ask. Okay, I'll address that question once we finish the solution to the current question. Okay. Okay, so now we have VIB. Okay, Once we have VIB, next we want G. Okay, so G already is free, as you see in the initial state. There's nothing on top of G, so we just pick up G and then we stack G on top of B. Okay, so this is the action. Next we want a Y. Okay, so we unstack Y from W and then we stack it on top of G. Okay, and we proceed in a similar fashion until we have R O Y G B I V in that particular order in the final state. Okay, and these are all the set of 16 actions that we have to follow in order to go from the initial to the final state in the shortest possible way. Okay, and once you sum up all the time units that is over here, you will see that it is 24 units of time. Okay, so this is the final answer solution to the problem. Okay, so I'll leave this screen on for a while and let you go through it so that you can be convinced that this is the correct solution. So yes, Vinay, so picking up takes 2 units and putting down takes 1 unit. This is something that the question told us to assume, that's why we are going this way. Okay, if the time units had been different, then we would have gotten a different set of actions maybe, or different sum total of the time that is required. And yes, so the blocks that are on top of the table, we need to pick them up, and the one that is already on top of another box, we need to unstack them, right? And then you have to place it back again. Then if you are placing it back directly on the table, we say we put down the box, and when we place it on top of another box, we say that we are stacking it on top of another box. Okay, so to address another question that was raised previously, what's the schedule for the next class? We will have the classes same time, same day every week. Okay, so today is Monday, 6 to 8 p.m. is the slot that we have. So next Monday again we will have another session that I will conduct. But then there is another session that is conducted on Saturdays. I don't remember the exact time for that, but you can check it up or look it up on the Swayam portal. It will also be repeated same day, same time every week. So if it's on Saturday at a certain time, it will be Saturday, next Saturday again at the same time. Okay, unless there is some emergency because of which the times of the sessions have to be changed. In that case, you will be notified of the change, if any. Okay. Okay, units is basically, you can think of units in terms of seconds or minutes. Okay, so we have not used any specific seconds or units or hours over here. We just go with units, and we assume for the sake of solving the problem some arbitrary number 2 and 1 for each of the actions. Okay. Yeah, so the stack, put down, unstack, pick up, these are all different actions that the robot can perform to go from one state to another. Okay, yeah, thanks for giving the time. Yeah, it's Saturdays, it's from 3 p.m. to 5 p.m. Okay, so there's another question about assignments. So yeah, this is one more thing that I should mention, that if there are any current assignments, okay, so for each assignments there will be a deadline. Okay, and you must check it up, look it up in the Swayam portal, and you must try to finish the assignment before the deadline, because otherwise it won't be counted towards your final score, right? So as long as assignment is active, I cannot discuss it in the live session, because that would be unfair to the people who are not attending the live sessions, right? So once the assignment date is over, after that we can for sure discuss the solutions to the questions in the current assignment. All right then. Any doubts in this question 2? So this is the second question's answer. Mm, this is in response to a question that was raised in the chat box. So the question asked, what is the time that will be required? Let me just go back. What is the shortest time in which you can reach the final state? And we saw that that will be 24 units. Okay. All right then. So I hope this question is clear. If not, let me know. We can come back to it again. So again, to address a question in the chat box, you can go to the Swayam portal and you can go to under each week. You will find a specific link that goes to that week's assignment questions, and on that page you will have the due date mentioned as well. Okay, you can check it out. All right then. So let's go to the third question then. Sorry about that. So okay, so we're continuing with the same problem setting, but the question is different here. So the question says, let's call the plan which takes the least amount of time to achieve the goal arrangement, which is the final state, as the best plan. Okay, assuming we don't care where the block W lies once the desired arrangement is achieved, where do you think it would be lying if you follow the best plan? Okay, so we just saw the best plan in the previous question, right? Now, where was W lying once we achieved the final plan? So, as some of your colleagues answered in the chat box, W will be lying on the table itself, right? Both W and M, okay? So, yeah, the block W will be lying on the table. That's a pretty straightforward answer. Okay, so there's another couple of queries in the chat box regarding the assignment. So, let me just share the screen with you and resolve it. Okay. So if you go to week 1 over here, right, you see a quiz over here. There will be some videos, all these videos that you should watch before answering the quiz. There are some lecture materials that are used in these videos that you can access through this link. And then there's a feedback form that you can fill if you have any feedback regarding the material covered in the in that week. Okay, and then when you go to this quiz over here, you will see a due date. Okay, for this one the due date is 2024-8/7. Okay, 23:59 IST. Okay, I suppose this is 7th of August. Okay, so this is your due date for week 1. Okay, similarly you will have a due date for other assignments as well. Okay, so you should just check out that due date and make sure that you answer or submit. So below there is a submit answers option. Okay, so make sure you fill in the answers and then submit them before the due date. Remember, before the due date you can submit as many number of times as you want. Okay, so you don't have to worry about getting everything correct in one go. You can submit as many number of times as you want. At least that is what happened in the previous iterations of the course. Once the due date is over, you won't be able to make any changes to your answers. Okay. All right then. Okay, two questions in the chat box. Why is W not placed above R? Because that is not what the final state desired, right? Final state didn't specify anything about W, so we are leaving it as it is. Okay. Prerequisite assignments are necessary. So I would suggest that you should solve them. That will give you a good idea of the good practice of the kind of questions that you can expect in the course. But are they counting towards your final score? No, I don't think so. Okay, so just for practice and getting yourself familiarized with the kind of questions and the kind of topics you might expect, you should solve the prerequisite assignments too. Okay, so let's move on to the next question. Okay, so this is kind of um, okay, a new kind of question, let's say. Okay, so we are done with the robot hand question, and this is the new kind of question. So it says that, can you recall this picture from the lectures? Okay, in what context was it used? Okay, so if you have not watched the lectures as of now, it's fine, don't worry about it. You can just guess what um, context might be from this picture that is shown over here. Okay, so there's a picture or an image of a policeman and a citizen. Okay, the citizen has asked the policeman for directions to some place, and the policeman is describing the way to go to that location to the citizen. Okay, now in the policeman's mind, the direction that he is telling the citizen is very clear. Okay, but what the citizen is understanding is a complicated mess, as you can see from the thought bubble on top of the citizen, right? So this is the context. Okay, and in what um now that you have the setting in mind, which of these options do you think is being conveyed through this image over here? Okay, so I'll let you think about it for a while. um, Sorry about that. In the meantime, I'll address some questions in the chat box. So how are these questions helping in AI? So good question. Okay, so AI is very vast topic, right? It can have things that are very trivial yet very subtle, and it can have things that are gigantic, huge, enormous, but very deterministic, right? And vice versa also. It can have things that are very small, but they are very difficult to comprehend, and it can also sorry, have things that are very huge, enormous, and still very difficult to comprehend. Okay, so it's a very vast area. In this course, we will take baby steps towards understanding what exactly are the fundamentals of artificial intelligence. Okay, and because we are taking baby steps, we are going to start with very trivial examples, and then we'll gradually build on top of those as we go through the different weeks of the course. Okay, so hopefully by the end of the course, by the 12th week of the course, you will have a decent understanding of um, uh, what becomes, or what are the fundamental concepts of artificial intelligence, and how you can solve various problems through certain heuristics that you will be coming across through the different weeks of the course. Okay, it belongs to which portion in the syllabus? That is something that I'll let you figure out. Okay, so I will let you go through all the contents from the weeks that are released as of now and will be released later on, and I will urge you to figure out which part of the syllabus this question will be from. Okay. Mm, okay, couple of more questions. No, for this particular course, I don't think you need to be very well versed in any specific programming language. Uh, there is a complementary course to the current course, which is called Knowledge Representation and Reasoning, which is also conducted by Professor Deepak Khemani, who is conducting this course as well. That requires knowing a language called Prolog to some extent, but you don't need to worry about that as of now. Okay, as of now, this is mostly a theoretical course, and you don't have to worry about any programming assignments. Although you are more than welcome and even encouraged to try to implement some of the algorithms or heuristics that you will be learning in the coming weeks of the course. That'll give you a better understanding of the concepts. Okay, all right, so I've spent a lot of time there. Let me get back to the question. Okay, so can you recall these pictures? In what context was this used? um, Okay, so the first question says to express the richness, ambiguity, and impreciseness of the natural language. Okay, this seems to be relevant, right? Because we communicate in a natural language, right? Like I'm speaking in English, some of you might speak in Hindi or Tamil or Telugu or Marathi or any language, right? uh, and these are all examples of natural languages, and these languages are very rich and very ambiguous and hence imprecise, okay, to some extent. What I may convey with certain intent may not reach you uh, exactly as I intended. Okay, there is some scope of some ambiguity or some misinterpretation always. So that is the quality of a natural language. That is a specific characteristic of natural language, and that is what is conveyed through this example over here. That the policeman is saying something to the best of his abilities, but the citizen is grasping only some parts of it. Okay, because of the ambiguity of the natural language. So option B is certainly not relevant over here to entertain the idea that AI is better than humans. That may be true with respect to certain specific problems, but that is not what is being conveyed to this example. Similarly, option C is also not valid, and option D is also not valid over here. Okay, so the correct option here is option A. Okay. Yeah, so thanks for suggesting. So anyone who might be facing problems with audio, yeah, you can surely try rejoining once or just disconnecting and connecting your audio device. That should help. Um, okay, so this was also a pretty straightforward question. I hope there are no doubts about this one. Cool. If not, then let's move on to the next question. Okay, this is another different type of question. Okay, so here you are given one English sentence. Okay, the sentence says Elizabeth told Lily. Okay, so Elizabeth and Lily are two different people. Elizabeth told Lily that she scolded her because she was in a bad mood. Okay, so who does she and she refer to? Okay, remember there are two instances of the word she in this sentence. One is colored red, one is colored green. Okay, so who could both of these she refer to? Think about it. Okay. Okay, so I see a number of people saying B is the correct option, a number of people saying A is the correct option, a number of people saying C is the correct option. Okay, so I also get a few people who say D is the correct option. Okay, so we have some votes for each of these options. That's great. Okay, now let's try resolving the confusion with respect to different options. Okay, so one interpretation of this sentence could be that Elizabeth told Lily uh, that she scolded her. Okay, wherein this she refers to Elizabeth scolded Lily because Lily was in a bad mood. Okay, so Lily must be in a bad mood. Maybe she did something. She let's say Lily is a small child. She did something wrong. She maybe threw some toys or something, and because of this, Elizabeth scolded Lily. Okay, so this could be one interpretation. Another interpretation could be Elizabeth told Lily that Lily scolded Elizabeth because Lily was in a bad mood. Okay, so in this case, Lily may not be a child, Lily may be a grown up individual, and it might be that Lily was in a bad mood, and it's just that she ended up scolding Elizabeth just like that. Okay, without any reason. This might also be one explanation. Another explanation could be that Elizabeth told Lily that Elizabeth scolded Lily because Elizabeth herself was in a bad mood, right? So you see, all the three options A, B, and C could be possible explanations, right? And this is what I was trying to say. Um, uh, conveyed to the previous question, which talked about the richness and ambiguity in natural languages. Okay. So the correct answer in this case would be cannot say. We cannot say. Okay. Okay, so in response to one of the questions in the chat, don't worry about the two she words being of different colors. That's just something I did to highlight the two instances of she. Okay. uh, Imagine the sentence without any color assignments. Okay. uh, no, it's not intentionally marked red and green, it's just marked to show there are two instances of she. Okay, so when you get this question in the assignment, it won't be colored, don't worry about it. All right, any doubts in this question? Okay, cool then. So let's move on to the sixth question then. um, okay, we have a similar sentence now, similar question, but there's a slight change over here. Okay. Elizabeth told Harry. Okay, now assume Harry is a boy. Okay. Elizabeth told Harry that she scolded him because she was in a bad mood. Okay. So in this case, who is she referring to? Here it's very clear that it's B, right? Because we assume that Harry is a boy, right? So we can say for sure that the person who is scolding and the person who is in a bad mood is the same person, and that person is Elizabeth herself, right? So here option B is the correct option. Here we can very easily resolve the ambiguity because of the way the sentence is constructed. Okay. Is my screen visible to others, or is it only specific to some people? Okay, cool. Okay, that's great then. Yeah, if anyone is facing any difficulty, please feel free to try to logging out and joining again, maybe, or try refreshing your screen once, or try changing the source of your net connectivity. Maybe one of these options should work. Okay, cool. So I hope there's no doubt in this question. If there is, please feel free to let me know. And yeah, once again, so the candidates or joinees who have raised their hands, please feel free to unmute yourself or write your questions in the chat box. You can lower your hands anytime you feel free. Okay, let's move on to the seventh question then. It's a similar kind of question, but the way the question is presented is a bit different. Okay, and the sentence is also different. So the Millennium Falcon overtook the Imperial cruiser because it was too fast. Now, what was too fast? Okay, what is this it referring to? B, that's right? Because here the sentence says that a Millennium Falcon, which is, let's say, a spaceship, that spaceship is performing the action of overtaking a certain other spaceship, which can only be done if it was moving faster, right? So what was fast? The Millennium Falcon is fast, or the ship that is overtaking or performing the action of overtaking is the fast one. Okay, now what if we had changed this sentence slightly? What if we had said the Millennium Falcon overtook the Imperial cruiser because it was too slow? Then what would be it referring to? Which is exactly what the next question asks. A, that's right? In this case, the Imperial cruiser or the spaceship which is being overtaken, that is too slow, right? So the correct answer is option A. Okay, so these few examples that you saw till now, where you take a specific word in the sentence and change certain other parts of the sentence, very very minute changes you make to the sentence, and based on that change, the the reference of that particular word, in this case it, changes, right? So here we are concerned about what is it referring to, and we change this word slightly. Okay, in the previous question it was fast, now it's slow. Because of this change, what this it is referring to changed from Millennium Falcon to Imperial Cruiser, right? These kind of examples are called anaphora resolution. Okay, and you may or may not have come across this if you have seen the videos or have not seen the videos, lecture videos yet. But don't worry, once you go through all the videos, you will come across these kind of concepts eventually. Okay, so that kind of answers this question that I was about to ask. The last few questions involved which of the following options then? A, that's right. So, like I mentioned, these questions involve something called anaphora resolution. Okay, you can also look it up. There'll be plenty of examples on anaphora resolution online. Any Wikipedia article should be more than enough to give a good idea. Even the lecture videos itself, for that matter, would be a good source of knowing about what these things are. Okay, so these few examples somehow tell us about the richness or ambiguity in natural language. Okay. Okay, so anaphora resolution is the correct answer. And also, as a side note, to address some of the questions, that was a question that was raised before, as in how is this related to AI. So in the bigger scheme of things, if you look at it, we as humans, we are able to look at the sentence and decide very cleverly what is a particular word referring to, right? What is it referring to? Is it the Millennium Falcon which is fast, or is it the Imperial Cruiser which is fast, right? That is easier for us humans to do. But if you ask a random machine to do it, it won't be able to do it so easily, right? Of course, now there are models, transformer models, or chat gpt, for example, which is a very very enormous deep learning model. Some of you may or may not have used it. That will be able to do these things very easily. Okay, but that is only because it has been trained with large amounts of data, right? So that is one bigger scheme of things that you can think about. In a more microscopic kind of view, um, this motivates us to also learn about certain things called formal languages. Okay, where we specify the entities that could form part of that language, the way this languages the sentences in the language are constructed, and there's a whole domain, a whole field of study around it. Okay, and that is also a very interesting research area in a part of artificial intelligence, and we will be covering some of those towards the very very tail end of the course, maybe weeks 11 and 12 of the course. And um, there is a whole other course which I mentioned before called knowledge representation and reasoning, um, which covers this in very in depth, in detail. Okay, so if you are interested, you can explore that later on, maybe in the next semester when it's offered. Okay, so right, so there's two questions which are kind of related to each other. What is anaphora and why is it not speech resolution? So there is no such term as speech resolution, at least not that I am aware of. It is just something that I coined up as an option over here. Um, but you can look up what anaphora exactly means, and maybe any Wikipedia article or even the lecture video should have an answer to your question. Okay. And as an example to what anaphora resolution is, we already have discussed so many examples, so you can correlate once you see the definition of what it is. Okay. Okay, so one of your friends has supplied a definition. Uh, you can check whether this is the same definition that you get. Okay. Okay. Let's move on to the 10th question for today then, which is a water jug puzzle, which is a very well-known, renowned puzzle in the domain of AI. Okay, so the basic setting of this problem is that you have three jugs. Okay, each has different capacities. Okay, the first jug, the leftmost jug, has 7 liters of capacity. The middle jug has 5 liters capacity, and the rightmost jug has 2 liters of capacity. Okay, and at any given instance, these jugs can be filled with different levels of water. Okay, and based on how much they are filled, based on how much each of these jugs are filled, we will define the state of the problem. Okay, so for example, consider this initial state. Okay, here the first jug, the leftmost jug, is filled with 7 liters of water, but the other two jugs, the middle and the rightmost one, are filled with 0 liters each. Okay, so the state over here is given by 700, which means that the first jug is filled with 7 liters, middle one with 0, and rightmost one with 0. So this is a state that we start with, and our intention is to reach the goal state where the first jug has 1 liter, middle has 5 liters, and the rightmost has 1 liter again. Okay, so we want to go from 700 to 151, and the actions that we can take over here are, we can either entirely pour out the water from one jug to another until the jug is completely filled. Okay, this is the action that we can do. We cannot take out any specific amount of water from a specific jug and then pour that specific amount into another jug. For example, in the initial state, the leftmost jug is 7 liters full, right? So we cannot just take 1 liter from that and put it in the rightmost jug. That is not allowed. We can either empty the jug completely, or we can fill up a jug completely. That's all we can do. Okay, and when we are emptying a jug into another jug, okay, that jug may not get completely filled. It may remain half filled or a quarter filled or something like that. Okay, so this is the problem setting, and these are the actions that you can take to go from one state to another. Okay, so I hope the problem setting is clear. If so, the question asks, starting from 700, what is the least number of transfers or moves required to reach 151? So I see some of you have already started giving solutions. That's great. I am very happy to see that. But let's wait a couple of minutes to, in the interest of the other friends who are trying to solve it, and let's discuss the solution after maybe a couple of minutes. Okay. Okay, so I'll once again like to re-emphasize that you cannot take out any specific amount of water from a jug and then pour it into another jug, right? For example, you cannot take 1 liters of water from 7 liter jug and then pour it into another jug. That is not allowed. Okay, you can either completely empty a jug or allow another jug to be completely filled up, okay, with water. For example, what you can do is you can keep pouring water from the 7 liter jug to the middle jug, which is 5 liter in capacity. Okay, so you can keep pouring water from the leftmost jug to the middle jug until it is completely filled up. Okay, in that case, the middle jug will be filled with 5 liters of water, and there will be 2 liters left in the leftmost jug. That is an valid action. Yes, the rightmost jug is 2 liters, not 1 liter. Sorry about that. Okay. Let's have a look at the solution then. So let me do one thing. Let me show you this. Okay, so this reveals the answer to a question that we were supposed to discuss later, but that's okay. So this is something called a state diagram. Okay, depending on the problem at hand, the state diagram may be very simple or very complicated. Okay, here we have a very simple problem at hand. Okay, so we can actually write out the whole state space and the whole set of moves that we can make manually itself. Okay, this is the small state diagram that we can make ourselves. Let's say, so this involved only 3 jugs, right? Let's say we have a problem that involves thousands of objects. Okay, then manually plotting won't help, right? Then we have to adopt certain algorithms or heuristics, which we will learn in due course of time in this course. In those cases, that those algorithms can be applied, but for now let's focus on the simple problem that we have at hand. Okay, so we were told to start with this 700 state, okay, which is the initial state, and from here there are some certain dark black arrows that are built, okay, which basically means that you can go back and forth from these states to one another. Okay, so from 700 you can go to 250. Okay, from 250 you can go back to 700, or you can go to 052. Okay, and there are certain states which are marked with this blue dotted edges. Okay, so these are the states that you cannot reach directly from any other state. Okay, these are states that could exist, that are valid. Okay, but you can only go from this state to any other state. Okay, what I mean to say is these blue dotted states, the 4 blue dotted states that you see, 331, 421, 511 and 241, these cannot be reached if we have 700 as the initial state. Okay, but these states could exist in other circumstances, and we could reach certain other states from these set of 4 states. Okay, so don't worry about it if it seems a bit confusing as of now. As we go through the solution, it will become clearer. Sorry about that. Okay, so let me do one thing. Let me try to draw out the solution. Okay, I hope you can see my whiteboard. So this is the state we began with. Okay, so we had 7 0, sorry about that, and 0, right? What we can do next is we can go to state 502. Okay, which means that we'll pour water into this jug until it is completely filled up, and because the rightmost jug is 2 liters in capacity, it will only retain 2 liters of water, right? So this will be filled with 2 liters, this will remain 0 liters, and because we have subtracted 2 liters on the leftmost jug, it will be of having 5 liters in itself, right? Does everyone agree with that? Cool. Then next what we can do is we can go from 502 to 520. Okay, which is we pour water into this one. Okay, so we completely empty the rightmost jug. Okay, and although the middle jug has capacity of 5 liters, it will only be filled with 2 liters of water. Okay, so we have 520. Next what we will do is we will make it 322. Okay, So we will again pour out 2 liters into this one. So now we have this already had 2, this will be filled up with 2 more, and this will be left with 5 minus 2, which is 3. Okay, so 3 2 2. Next what we will do is we will pour out the water in the rightmost jug into the middle jug, so we will get 340. So this will remain 3, this will become 4, and this will be, sorry about that, I'm using a touchpad to draw, so the drawing is horrible, but please bear with me. Okay, so we have 340. Next what we do is we further pour out 2 liters into the rightmost jug. Okay, so we again do this. So this will be 4, this will be 2, and this will be 1. Okay, now can anyone tell me what should be the last step for us to reach 151? Exactly, we keep emptying the rightmost jug into the middle jug until the middle jug is completely free. Now we know that the capacity of the middle jug is 5 liters, which means it will only take in 1 liter more, right? So what we will be left with, this will remain 1 liters, this, the middle one, will become completely filled up, so this will be 5, and this will have only 1 remaining. Now we have reached the final state. Okay, I see someone has unmuted themselves. Is there a question? Any doubt? Okay, no problem. so how many steps did we take? This was one transfer, second transfer, third, fourth, fifth, and sixth, right? So in 6 transfers we were able to go from the initial state to the final state. And now let me get back to the state space diagram that we had constructed. And if you see, the exact path that I have taken is 700 to 502 to 520, 322, 340, 142, and then 151. Okay, so this involved 6 jumps, 1 2 3 4 5 and 6. This is not the only path. We could have gone the other way as well. We could have gone 700 to 250, 232, 430, 412, 610, 601, and then 151. But this would involve 7 hops, 1 2 3 4 5 6 and 7, right? And what we were asked is the shortest possible way to go from 700 to 151, right? And that would be the 6 hop path that we just discussed. Okay, so let me go back to the question then. So what is the least number of transfers required to reach 151? That will be 6. Okay, any doubts in this question? Okay, great. There are a couple of questions in the chat box. I'll just address them. So there was a question about, can we do 1 in 4 and 2 remain same? Can you elaborate more on this question? I'm sorry, I couldn't grasp what you were trying to ask. But if you're asking about a separate state that you want to reach instead of 151, for sure we can reach any possible valid state from one initial state to another state. Okay, this is just an example of a goal state. How I got the diagram. So this is something that uh, I got it from my seniors, but as in my senior TA who had framed this question. But you can draw this diagram yourself. So this was a very simple problem, right? So what you can do is that you can write out the 700 state, okay, and then think about all the valid actions that can be performed. Depending on each action that you perform, you will go to a different state or the same state, right? So all the different states that you get, depending on the action you took, you form an arrow and write down that state, okay? So that will add some nodes and some edges to your graph, okay? Then you take another node that you just added and you repeat the process, and finally you will see that you have formed all possible states that could have been reached and all possible ways that you could have reached. And this is for some small simple problems that I'm talking about, okay? If it's a large problem, like I said, drawing the whole state space manually is not a efficient solution. Then they will adopt heuristics that we will learn later in the course. Yeah, it's very similar to Tower of Hanoi. That's a great observation. No, there's no specific theory to draw, but it's good to think about it. So different people can adopt different strategies to draw these state space diagrams. Okay, you can start with one state and then expand based on the actions that you can perform. Some people, what they like to do is they first like to think about all the valid states that could exist, and then they make all the nodes, and then they connect edges between different nodes based on what are the actions that could connect those two, uh, transfer of water between those two states. Okay, that is also a valid approach. Whichever feels comfortable to you, you can adopt. There's no specific theory to draw these diagrams. um, the last sentence of the question says that one can either empty a jug into another or fill another jug to its brim. It's like what I said, right? You cannot take out any specific portion of water from a jug. You can either completely pour out a jug until into another jug until it is completely full, which is what is meant by filling another jug to its brim, which means the lid of the jar. Okay. Okay then. Any other doubts in this question? Why can't we fill the second jug in one go? We can do it, but then we will have to take certain extra steps to reach the final goal state. Okay, like I showed in the state space diagram, um, you could go from 700 to 250, which is what you are saying, right? Filling the middle jug to its complete to it completely to its brim. But then you will have to take some extra steps to reach 151. Remember, this path took us 7 steps. You can reach 151 in 6 steps alone by choosing to go via the 502, 520, 322, 340, 142, 151 path. Okay, so it's just a question of efficiency, not a question of whether something that you can or cannot do. Okay, so yeah, any other questions? So one activity that I would encourage you to do is, here we took 700 as an initial state, right? You take one random state, valid state, as the initial state. Okay, say something like 4 to 1. Great, yeah, 4 to 1. And then see, and then decide another goal state. Okay, and remember another valid state. Okay, and then you try to figure out the shortest way in which you can reach from that initial state to the new final state that you decided. Okay, that would be a good activity for you. Okay, so cool. Then let's move to the next question. Some of you might have already seen the answers as I moved the slides, but let's assume that we haven't. Okay, and let's focus on the question. So starting from 151. Okay, so remember now we are starting from the goal state. Okay, what is the least number of moves or transfers required to reach 700? Let me go back to the state space diagram so that it's convenient for you. So now we are starting from 151 and we want to reach 700. 2. Yeah, very good. So here we can just do with 2 steps alone, because we can go from 151 to 250 and from 250 to 700, right? So 151 to 250, 250 to 700, 2 steps alone, 2 hops. Okay, so the correct answer would be 2. What is the size of the state space? Number of states in the 752 water jug problem. So 752 water jug puzzle means that the capacity of each of the jugs is 7, 5 and 2 respectively. Okay, you can even do an activity where you change the capacity of these jugs. You can, let's say you have 8, 5, 9, something like this, right? And then see that whether there is a solution that can be achieved in a simple way. Okay, by the way, 859 is something that I mentioned arbitrarily. Okay, you can take any number you want. Depending on what number we choose, sometimes we may or may not have solutions. But yeah, it's a good problem to explore in the free time. Okay, so coming back to the question, it asks us what is the size of the state space. And as you might have seen, if you count the number of nodes over here, there will be 14 black nodes and red node, and 4 these blue dotted nodes. Okay, so total of 18 nodes. 14 only if you consider the states reachable from 700. Okay, that is the size of the state space. Okay, so I'll leave this screen on for maybe a few seconds so that you can fully look into the state space and convince yourselves if there is any remaining doubt about this question, and then we shall move on to the next thing. Okay. Yeah, please go ahead. Okay, but there is no direct connection, uh, but you can reach it via 502, right? Yeah, you can have intermediates. Yeah. So the question just asks us what is the total number of states that could exist. Okay, it's not necessary that you have to reach them in one hop alone. But that's a good question. Thanks for your question. Okay. Any other questions about this problem or anything that we discussed before? Sorry about that. Okay, cool then. So that actually brings us to the end of questions I had for you guys today. Okay, so this was kind of sort of a mixture of introductory questions and week 1 questions, sort of, that you might expect. uh, because week 1 and week 0 are introductory weeks, uh, a lot of these questions might seem either very simple or a bit confusing, both of which are valid feelings, I would say. In my opinion, when I took the course, I felt some questions were very easy, and there were also some questions which I felt that didn't make any sense at all, and it's completely fine. But it's good to have an idea of the kind of questions that you might expect in the coming weeks, right? And this will hopefully help you to some extent with that. And yeah, as we go through the next few weeks, we'll get into more specific and more detailed concepts, algorithms, and heuristics. And yeah, those will be a new flavor of um, questions that we will come across. Okay, there are a couple of questions. How can we arrive at 421? So, like I said, if we have 700 as the initial state, we cannot arrive at 421. But 421 is a state that could exist in itself. Okay, it's a valid state. Given the configuration, the 752 water jug puzzle that we have at hand, and we could reach other intermediate stages or states through or from 5421. That's the only reason we have kept those four blue dotted states in the state space diagram, just for the sake of completeness. Okay. What are the future advantages of taking this course? um, you will get to learn a lot about the basics of artificial intelligence. I would say that it's a bit of a theoretical course, full disclaimer. Um, so if you are expecting that this course might have certain concepts about the traditional things that are associated with AI, like machine learning or neural network models or things like that, those are the topics we won't be covering in this course. Okay, so you can have a look at the syllabus and you can see if it seems interesting to you. um, there are different courses for that, for neural networks and deep learning, machine learning. There are separate, very well structured courses for that. But this course is mostly a theoretical course that provides the fundamental ideas about heuristics and search problems, solving search problems in AI in efficient ways, right? Some of you who might be from a computer science background, who might have done their bachelor's or some level of schooling in computer science, you might be aware or familiar with things like breadth first search and depth first search, right? Is there anyone who is familiar with that? Okay, no worries. If not, that's completely fine. We will be covering that as well in the upcoming weeks. Okay, we have some people who are familiar with that. So, those are some of the basic ways in which, let's say you have a problem where you want to go from one location to another location, and there are several intermediate locations in between, right? And there are several ways of doing that. This breadth first search and depth first search are two such ways, but they have their own drawbacks and shortcomings. In this course, we will learn methods that will be much more efficient and much more intelligent in choosing the most efficient or optimal way of going from our starting location to our ending location. Okay, so in those terms, this will give you a flavor of what AI could do, right? So yeah, it's to me it's a very interesting course. But yeah, you can explore the syllabus and see if it suits well with your interests. And yeah, it's always good to have these skills in hand when you uh, go into the real world, into a job or into research anywhere. Okay, so that's the takeaway I would say is from this course. Recommendations I can, but I will refrain myself from giving recommendations, because I feel that it should be the student's decision of which course to take, right? You should go through all the courses that are available, and whichever seems most interesting to you, you should go ahead with that. Okay. No, there will be no assignment for the live sessions. Don't worry about that. There will be assignment based on the specific lecture videos, okay, and that will be available in the Swayam portal, but not based on the live sessions. In the live session, we will discuss questions that might help you in the assignments, but not directly. Okay. Yeah, thanks for your feedback. Yeah, I also see the problem of this constraint in members. I'm not sure why that is happening. I have previously conducted these live sessions, and those used to have much more than 100 participants before. I'm not sure what exactly is going wrong. I didn't change anything, but I'll look into it and hopefully resolve it by next week. Um, yeah, I'll see what I can do. In the worst case, if we are not able to resolve the issue of having 100 participants, you can always have access to um, the recordings of these live sessions, right? You can always revisit them at any point of time and look at all the questions we had discussed. There's another forum that I will highly encourage you to use. I'll show it to you. So if you go to the Swayam portal, right, um, and the reason I'm saying this is because we have limited time available to us in these live sessions. um, so there is this Q&A tab over here, right? If you click on it, it will ask you to go to another page. Click on continue, and this will lead you to a forum, a Google group, where several of your colleagues ask questions. Some of you might have already used it, some of you might not be familiar with it, so that's why I'm sharing this with you. Okay, someone has already shared that they were unable to join the problem solving session. That's unfortunately that's not in my hands as of now, but yeah, I will see what I can do about it. But yeah, so I just wanted to show you this forum. You can post your questions over here, and the questions that we cannot address during the live sessions will be answered by, you see Bhaskaran sir over here, right? He is the main T, the lead T of the course, and he will address most of the questions that are asked on this discussion forum. Okay, so I highly encourage you to make the best use of this forum as well, apart from the live sessions. Where can we find the old live session videos? Good question. So um, I can do one thing. I can share the link with you, but let me just wait for it, okay? Because once the link to the recorded videos is shared with you guys, to all the enrolled people, that link, that video will be uploaded on the channel which already has pre-recorded previous year's videos. Okay, so you can always find that on that YouTube channel itself. Okay, so it will be shared with you soon, don't worry about it. Yes, the slides that I showed will be shared with you. Okay, someone had asked about the 12th question. I'll just leave the 12th question before you so you can have a look at it. How to start with the prerequisite assignment. So the prerequisite essentially aims to give you a flavor of the kind of questions that you can expect. Sorry, I'll just share the screen. Yeah, so just use your best. You don't need to study anything specific for prerequisite assignment. Just try answering the questions to the best of your abilities based on your logical reasoning, okay? And then see how much of that is matching with the answers, and based on that you'll kind of understand how to approach the problems in the coming assignments. That is the idea of the prerequisite. And as far as I remember, I think once you submit the answers on the prerequisite assignment, it immediately shows what is correct and what is incorrect, right? So you'll get immediate feedback as well. Okay, so yeah, I hope question 12 is okay to the person who had asked. Before ending the session, let me introduce you to our motivate you to another problem. Okay, so we saw different problems till now, right? We saw the robot problem in the initial few questions. We saw the water jug problem. There's another problem that's very famous in AI, and that is called the missionary cannibal problem. It's known by various names. Okay, some people call it the goat and the man and the tiger problem or things like that. Okay, there are different variations of this problem. The basic idea is that there are three people who are missionaries, and there are three people who are cannibals. Okay, and as the name suggests, the missionary people, they're very peaceful people. They don't want to cause any violence. The cannibal people are a bit violent. Okay, they can kill and eat other people. Okay, and then you have a boat, and then you have a river. Okay, and your aim is to go from this initial state where all the six people are on the left side of the river to the you want to go to the right side of the river. All of the people want to go to the right side of the river, but the problem is you have only one boat. Okay, and there is a restriction on the number of people that can exist in a boat at a time. Okay, I can't remember the exact restriction, but you can look it up. It will be there on Wikipedia for sure. Okay, so that's the search missionary cannibal problem on Wikipedia. You will find a complete explanation to the problem. You also cannot have both missionary people as well as cannibal people on the boat at the same time, because then they will get into a conflict and some violence will happen. Okay, you also don't want to reach an intermediate state where at any point of time there are more number of cannibal people than the peaceful people, because again violence will happen. Okay, so keeping all these constraints in mind, what is the shortest path in which you can go from initial to the goal state? Okay, so I will encourage you to think about it, and um, yeah, and try to solve this problem in your free time, and I hope you enjoyed solving it. And yeah, if you want, we can discuss this again in the next live session when we meet, but I would urge you to give some thinking, some time to this problem. Okay. uh, I'm grateful for your feedback. Thanks for sharing that. um, yeah, this was in response to something in the chat box. Yeah, it's great that you are familiar with the lion goats problem and the other constraint as well. Thanks for sharing that as well. Okay, so before concluding, I'll just give some acknowledgements to Professor Deepak Khemani, of course, for framing this whole course, for constructing this course from the scratch. Bhaskaran sir, who like I mentioned, he is a lead TA, and he has been gracious enough to provide us all the material for this course. And then of course the NPTEL team, PMRF team, and my department. Okay, so yeah, any other questions before we end the session? Yeah, please feel free to speak up. Mm-hmm. That's what one of your friends said in the chat box. I will request you to verify it, because honestly I can't remember it at this point of time. But yeah, it should be available somewhere on Wikipedia. So yeah, that should help. Sure, no worries. Yeah, so this was the question. We wanted to go from 151 to 700 in the minimum possible hops. Yeah. Anything else? Yeah, please go ahead. Yeah, you're audible, Satish. Maybe there's a lot of noise in the background. Yeah. Mm-hmm. Exactly. These four blue states are ones that cannot be reached from 700, but they could exist. Yeah. Yeah, this could exist in the sense that these are valid states from which you could go to another state, but you cannot reach these states from 700, right? So from 700, if you have 700 as the initial state, you cannot reach these states. But let's say you had some other initial state from which reaching these four blue states or some of these four blue states was possible, then the state space diagram would change slightly, right? Then some other nodes will be unreachable and these would be reachable. Does that help? Mm-hmm. Mm-hmm. Yeah, so that's a good question. I think that depends on the way the question has been asked. So the reason I included this question is, so maybe you can mute yourself, Satish, while I'm answering. Yeah, thanks. So yeah, so the reason I included this particular question is because this was asked in one of the previous years, and at that time the question didn't specify whether they want only the states that are reachable or all set of states possible, right? So depending on how you interpret the question, the answer could be 14 or 18. Okay, but since then this was brought up in the forum and the team corrected it. Bhaskaran sir was involved at that point of time, and they resolve the conflict, right? So in the future, if such a question is asked, hopefully that will be precise enough, and this will that will mention exactly what it wants, so that you'll be able to answer uh, whether they require only reachable states or all states. Okay, but yeah, that's what I wanted to share. Does that answer your query, Satish? Okay, great. Okay, so this another question. Is there any course regarding AI with programming? There must be, Yashu. Unfortunately, I'm not aware of it, but you can explore the list of courses on Swayam and see if there is anything that fits well with your requirements. So another question is, can we set maximum 3 people to go on one boat? Um, Once again, I'll encourage you to look into the Wikipedia page. If there is a possibility of having 3 people, you can explore that problem as well. Although I can see why that would create problems. But yeah, I'll let you explore the possible solution to it. Okay then. Anything else? Cool. If not, then let's end the session for today and see you next week, same time. Okay. All right. Have a good rest of the evening.